Well, happy Thursday, everybody, and welcome to yet another Ball Publishing webinar. I am Chris Beatties, editor of Growertalks, Green Profit, and the e-newsletter Acres Online, and I'm going to be your host for the next hour or so today as we tackle today's topic. There you see it on your screen, building better plants with biologicals. Now, I've been in horticulture for, dare I admit, 40 years now. And it's amazing how much to me, it's amazing to me how much we're still learning about what is arguably our most important input, and that is our potting media. Now, we used to use, back in the day, field soils, right? Dug right out from behind the greenhouse. Then it was in the 1960s, I believe, when Cornell professors James Boodley and Raymond Sheldrake created the so-called soilless medias, which we've been using and refining ever since. But we've come to realize that incorporating some ingredients found in natural soil into our soilless mixes can give us the best of all worlds: cleanliness and consistency, control, and a beneficial microorganism biome. Now, while I have bought thousands of bags of professional potting mix over the years, especially when I was running a greenhouse, I have never used one that contains beneficial microorganisms. So I am not an expert on the topic, but I am an expert at finding experts. And today's expert is Mr. Nathan Wallace Springer. He's horticultural specialist for the Southeast U.S. for Premier Tech Horticulture of Quebec, Canada. And Nathan's going to discuss the features, benefits, and return on investment, very important these days, on several popular beneficial media additives, including Bacillus, pumilus, and mycorrhizae. Am I correct there, Nathan, in what I just described?
Yes, you are today, Chris. How are you doing today?
Very good, very good. Now, Nathan, I always like to find out where you're broadcasting from. Obviously, a backyard greenhouse that you've got. Very nice little research facility.
I'm coming in from Tampa, Florida today.
Tampa, Florida. And something I learned about Nathan, he and I are both University of Florida graduates. A couple of years apart. Just a couple.
Just a few.
Just a few, but that's okay. I broke ground there for you. And you also, you got your undergraduate degree in ornamental hort there, is that correct?
No. So for University of Florida, my undergrad was in environmental science.
Oh, that's what they call it now.
Yep. So I did environmental science, and then at Auburn University, I did my master's, and I got my master's in horticulture.
There you go. And you're back in Tampa now. So how did you come to Premier Tech? What put you into the world of potting mixes and peat moss?
You know, that's an interesting topic because I actually did aquaponics and hydroponics, which did not have media involved. But
I don't need any stinking media.
But my boss found me, and he found me and he recruited me. So I've been here at Premier Tech for about 3.5 years.
Well, that's very cool. That's very great. Both great methods of growing, and they have their places, but we're happy to have you. Let's see. As usual, I am working the controls from the Ball Publishing broadcast studios high atop the Ball Publishing Tower in West Chicago, Illinois. Now, real quick, let's do a little bit of housekeeping because people ask, how can I ask questions? We want you to ask questions. Nathan's going to go through this really quickly, and he's got some great information. If you want to ask questions, use the Q&A tool on your dashboard. And the first question I always get is, will this webinar be archived? And yes, it will be archived at the same place you signed up, conveniently enough, growertalks.com/webinars. And that, as always, is the only two housekeeping slides I have. Maybe someday I'll have to add a third one. So Nathan, why don't you go ahead and share your screen, just like we practiced, and take it away. And as we have questions, if they're pertinent to what you're talking about, I may interrupt you and pop in. Otherwise, we'll save some time at the very end. So take it away, Nathan.
All right. Hello, good afternoon. My name is Nathan Wallace Springer. As Chris said, I'm a horticulture specialist here at Premier Tech. Today, I will be giving you all my grower service talk on building better plants with biologicals. So without further ado, let's get on into it. So when we go, I'm going to give you a general overview to start of the topics I'm going to be talking about today. So the first one I'm going to be talking about is active ingredients. What are active ingredients? And what is their role in plant production? Why do we need them? I'm also going to be going over the classifications for active ingredients, such as biostimulants versus biocontrols. What do these terms mean? As well as I'm going to be talking about the different types of active ingredients that are out there and which classification that they fall into, such as mycorrhizal fungi. I'm going to be going over endomyc versus an ectomyc, as well as I'm going to be talking about propagules versus viable spores and this debate that is occurring out there in the industry. And I'm also going to be talking about Bacillus bacteria, and I'm going to be going over one strain versus many, which is better for plant production. And finally, I'm going to be finishing up with the cost effectiveness of active ingredients today. So in order to learn about something, we have to be able to define it. What are active ingredients? Well, active ingredients are simply biological microorganisms that we have selected for their ability to enhance plant growth, reduce things that we don't want in our greenhouses, like insect populations or plant pathogens, as well as improve media characteristics. So two types of classifications are going to be biostimulants and biocontrols, which we're going to get into in a second here. And some examples of active ingredients include things like bacteria, mycorrhizal fungi, streptomyces, and insects. So one of the questions I get is, why do we need active ingredients in our growing media? Well, it's important to realize that growing media is different than mineral soil. So in mineral soil, if we go out into our backyard and we take a shovel and we scoop up some of that dirt, well, that's going to have natural microbes in it. Soilless media has been made from components like peat, pine bark. You might have some things like cocoa coir or wood fiber in it. Well, those are organic components that don't actually have a lot of natural microbes associated with them. Additionally, we might have mineral components like perlite and vermiculite, but those don't have microbes in them. So what active ingredients is doing is putting more of those biologicals back into the growing media. But what we're doing is we're selecting the best ones out of the hundreds or thousands or millions that are naturally found in organic mineral soil. So my first picture is a little bit of a teaser. This is a root colonized by mycorrhizal fungi. And this is going to show you, by the end of this PowerPoint presentation, you're going to be able to identify these structures, and we're going to be able to talk about what they are. So biostimulants versus biocontrols. What are biostimulants? We can think of biostimulants, if we look at the word stimulant, we're stimulating our plant growth. Our goal is to improve our nutrient uptake. We might improve our tolerance to stresses like water deficiency or, sorry, nutrient deficiency or water, if our plants are suffering from water loss, or we might be trying to improve our crop quality and yield. So two types of bacteria are going to be, or two types of biostimulants are going to be our bacteria and our mycorrhizal fungi. And my question is, what does this mean for you as a consumer? Because you're probably thinking, Nate, these terms mean a lot of things, but nutrient use efficiency, I don't get it. Well, this means a couple things. First and foremost, if our plants are taking up more nutrients, they're going to be growing more fast. They're going to be growing faster and more uniform. Additionally, we're going to be seeing shorter grow times. If our plants are able to use nutrients more efficiently, now, depending on which species we use, we might be able to knock off a day to a week. Well, that means that we're saving money on bench space and other factors in our greenhouse we need to consider. Additionally, how does increased yield sound to you? Imagine if you were a tomato grower or a cucumber grower, and you're growing 10,000 plants and you got an extra 3 to 5 pounds per plant. Well, that means more revenue is going to be coming back to you in the long run. And lastly, we can think about this as from a cost savings perspective. If our plants are taking up more nutrients and they're growing healthier, we're not going to be seeing as many die off to things that we could have prevented, like plant pathogens or insects, because they're going to be healthy and growing beautiful and uniform. So in contrast to biostimulants, we have biocontrols. We can think of biocontrol in the word control, meaning we're looking to control something. We're looking to suppress, control, or regulate something that we don't want in that growing media, like insects, weeds, or root rot diseases. So three types of biocontrols that we have out there in the industry are going to be things like bacteria, mycorrhizal fungi. We might have insects. In terms of this webinar, we're going to be going into the former two rather than insects. But what does this mean for you? Well, it means a couple of things. First and foremost, if our plants are growing healthier and we're suppressing things, well, we're going to have reduced crop damage and we're going to see healthier plants because we don't have those factors that are killing them off. Additionally, we're going to reduce our crop shrinkage because we don't lose plants to fungal diseases or root rot diseases. So what does shrinkage mean? I'm going to be going over that and using that term, but shrinkage basically means the gradual loss of plants at various points in the supply chain process. For example, if we started out with 10,000 tomato seedlings and 100 of them didn't germinate, and then we lost a couple due to watering or because of growth issues, and then we lost them when we transplant them out in the field, well, if we take that total amount that survives and we look at that as a percentage, that's what we're going to be talking about as crop shrinkage. And lastly, we can think about biocontrols as a way of saving money. For example, if we don't encounter things like Pythium and we're not seeing things like fungus gnats or thrips, well, we don't have to apply those pesticides or those fungicide drenches or those insecticides as often. And now imagine the labor associated with that. This is how you can think of biostimulants and biocontrols are going to benefit you in your greenhouses. So our first microorganism today that we're going to be talking about is going to be mycorrhizal fungi. And there are two types of mycorrhizal fungi. There are endo and ectomyc. So if we break down the root word of this, we're looking at endo is Greek for within or inner, myco is Greek for fungus, and rhiza is going to be Greek for root. So if we put that together, we're talking about something that is going to penetrate a plant root cell, which is what an endomyc does. And this is going to be colonizing roughly 85% of all plants, such as annuals, perennials, and vegetables. So if you were a poinsettia grower right now, if you were a mum grower, if you grow Easter lilies, if you grow pansies or petunias, these types of endomyc are going to benefit you. Conversely, we also have ectomyc. So if we take the root word of ecto is going to be Greek for external, myco is Greek for fungus, and rhiza is Greek for root. We're talking about something that's going to colonize the outside of the plant root today. And this is going to be roughly 10% of all plants, which is primarily our conifers and oaks. So if you are a Christmas tree grower or you grow pecans or hazelnuts, this is what you're going to be using to grow your plants. So I've attached this picture today for you all to be able to see. So if you look at the right side of my picture, we have what's an endomyc. So we have essentially a spore. A spore is germinating a hyphae, which is this filament that is attached to that root. And then you'll see that it produces a viscule or it's going to produce an arbuscule. So a viscule is basically a site that's going to store carbohydrates and things like that, or lipids. An arbuscule is going to be a way for it to exchange nutrients like phosphorus and water. Conversely, compared to an endomyc, we have an ectomyc. An ectomyc is going to be colonizing that outside of that plant root and forming a network along it. And lastly, it's important to note that 5% of plants do not respond to either, which is going to be mainly our Brassiaceae and Ericaceae families. Now, Brassiaceae are going to be things like our kale, cabbage, and broccoli. And Ericaceae, it is important to note we do have a mycorrhizae that does colonize some Ericaceae plants, like blueberries, and we can use an ericoid mycorrhizae, but a lot of that is not commercially available, and it's not there yet. And then we also have things like beets and mustard that also are not colonized by either endo or ectomyc. So when we talk about mycorrhizae colonization, there are going to be 4 C's of colonization. The first phase is what we call the call phase. And during that call phase, we're seeing a spore right here up in the top right corner, and that spore is waiting for a chemical signal from a root. Once it receives that chemical signal, it's going to grow and it's going to produce a hyphae to grow in contact with that. And that's going to form our second phase. Now, the mycorrhizae that we're seeing right here is an endomyc because it just grew into that plant root cell and it produced an arbuscule. And then the final phase of colonization is completion. And during completion, we're pulling in additional water, nutrients in that media like zinc, phosphorus, that the plant can't normally access or has a difficult time accessing. So when we think about these phases, Our first two phases are going to be what we call the pre-symbiotic phase. And these take roughly between 14 and 28 days to colonize plant roots. Our next two phases are going to be called the symbiotic phase, and these are permanent. And what do I mean by permanent? I mean that these will stick with the plant after it has reached completion. It will go, if you sell your plants to retail, if you sell it to consumers, or if you transplant that plant into an actual field or soil, it's going to stay with that plant for the remainder of that plant's lifetime. So I have my first video of you for the day for you all to see, because I think this is really important to see what this is. So I'm going to pause it here. And if you see on the left side of this picture, what you're seeing, this spiky figure right there, that is a plant root. If you see the other aspects of it, that kind of look like spider webs, those are going to be the hyphae and the growing media that are growing towards that plant root or trying to colonize that. And then the little egg-like things, the round parts that you're seeing, are actually the spores that have germinated. So when we start to see and we start to zoom in on it, I'll pause it here. This is a picture of the mycorrhizal spore that is germinated, and we're seeing the network of hyphae that is going to that plant root. And I find it fascinating because once we zoom in around 100 times magnification, we can actually see the nutrients moving from that plant or from that mycorrhizae into the hyphae going transported to that plant. And that's how our plants are benefiting. These are acting as a secondary root system to that plant. So in terms of mycorrhizal fungi, I wanted to show you all a couple of pictures. Our first picture is going to be Rhizophagus irregularis. And the reason, and what you're seeing here is you're seeing that these plants have been dyed. And what you're seeing here is the vesicles inside the plant root, and you're seeing a few arbuscules. And a couple of reasons why we're looking at this is because you can see whether or not a plant is colonized. You can see whether or not a plant is going to be an ecto or endomyc based on its colonization. You can see whether or not, one mic is more effective at colonizing a plant root than another type of strain. And you can also see for us, like, whether or not the amount of mic that we're putting in our growing media is proportionate to what we're seeing or what we want to see from our root systems. So we can use these to determine if we need to add more to our growing media. So some of the benefits of mycorrhizae. First and foremost, we're going to be seeing an enhanced nutrient uptake, and we're going to be seeing reduced nutrient deficiencies. So our plant is going to be pulling in more copper, more phosphorus, zinc, and manganese into our plant. Additionally, we're going to see a reduction in fertilizer use. We don't need to apply as much because we're no longer wasting as much. Instead of leaching it out of the growing media, we're actually going to be retaining some of that through our new connection with our new roots, our secondary root system of mic. Additionally, mycorrhizae work best when a plant is under stress. They will pull in more water, which will delay wilting and will delay those nutrient deficiencies. Additionally, we are going to see improved plant growth and rooting. And I'll show you a picture here in a second that kind of solidifies some of the benefits of mic. Additionally, we're going to see things like reduction of salt toxicity, and we're going to see increased flowering and fruiting. And I'll show you a picture here of that in a second as well. So I know at this point, you're probably thinking, Nate, okay, this all sounds nice, but I'm a great grower. I don't have nutrient deficiencies in my greenhouse. My plants don't ever wilt. Why should I buy mic? Why should I use a mycorrhizal product? Well, let me ask you a question on that. We grow plants in a greenhouse and we're watering them according to their needs. Are your customers going to provide that same care? So I wanted to show you all a picture. Here are a couple pictures of us using mycorrhizae. So this is a product demonstration that I did down in Florida, up in Apopka, and we have a picture of coffee here on the right side of our screen. Now the plant that you're seeing to the left did not have any mic or bio. It still grew, but you can see that the plant with BX, which included the mycorrhizae, it grew bigger and healthier. The leaves were better. When we look at other plants that were done in this product demonstration, we can see the rooting difference. This shows you the difference between look at the root nodules compared to a plant that doesn't have mic. You can see how big they are comparatively. And the plants that had mic, not only did they grow faster, they were greener, they were healthier, they didn't die as much. We didn't have any issues on them, and their growth was a lot more uniform, and we weren't seeing any type of uneven growth in that greenhouse. So again, you might not necessarily need or will benefit from your mic, but I guarantee you your consumers will. Your consumers are going to remember that plant that lasted them from spring to summer, that they might have watered once and fertilized, versus the plant that, you know, lasted them 3 weeks, so they went on a mini trip and came back and was dead. You know, that mycorrhizae is going to benefit your plants. So this is another experiment that I did up in Georgia, and I wanted to show you all the difference between a mic versus a not mic product. So on the left side of your screen, you're going to see a picture of without it. And now whenever I select plants for pictures, I make the head grower go out there and look at the plants with me. They select the average. And what was really cool about this product demonstration is we actually had 2 greenhouses, and we had an injector issue, and one of them, something went wrong, but because we weren't putting out at the right nutrient level, 1/2 the greenhouse actually went nutrient deficient and yellow, but the one that stayed bright green was the one with mic. So, oh, we had a question come in. So next, I want to talk about this debate that's in the industry right now, which is viable spores versus propagules. Well, what's the difference? We can think of viable spores as the seeds to a plant. Yeah, sure, I can take any part of a plant and go and make a new plant. I can take the roots, I can take the stem, but what's most likely going to establish a new plant is going to be the seeds. Well, you can think of viable spores as the fungus's reproduction. It's what's most likely going to establish a new symbiotic point with that plant. Conversely, propagules can include viable spores, but they can also include things like root fragments, arbuscules, hyphae, and things like that. However, the issue is those are less likely to form a mycorrhizal symbiosis with the plant. You know, it sounds good to hear, hey, my product has 100,000, you know, propagules in it. But if you tell me it only has 5 spores in it, that product is probably not going to do a whole lot. Also, you can think about viable spores as that casing. It allows them to be more resistant to harsh environments. So if we need to store it outside, it's going to survive in those. And that viable spore is going to last a lot longer than the propagules will in a lot of these products out there on the market. So I wanted to show you what I mean by spores versus propagules. This first picture on the left side of our screen is what an actual viable spore is. You can see that spore seed, and you can see a little bit of the hyphae coming out of it. Conversely, the next 3 images are going to be what we call propagules. All of these can be classified as propagules, but with propagules, you can get things like hyphae fragments. You can see that that's a root fragment there with the vesicle, but you can also get them with arbuscules in it too. You can get non-viable spore as well. Now you can start to see, well, which one do I want in my greenhouse if I'm going to go buy a product? Well, we don't really want these other things because those aren't going to establish the connection with the plant. What's going to establish the connection with the plant in most cases is going to be the viable spore. So again, it sounds really good to have 100,000, you know, propagules in your plant, in your inoculant, but how many viable spores? What's going to produce my connection site? That's what we need to be looking for in our products. So occasionally, I'll get the question, Nate, how consumers identify products that will provide real or actual results based off of what you just said? Well, the first solution, the simple solution, is to check the label. We need to be looking for the viable spore count and not the propagule count. If these numbers are not listed or the manufacturer can't provide them to you, I would not go with that product. Chances are it is not going to be a product that is going to work, and there's something shady going on there. You know, not all propagules are also created equal. You know, here at Premier Tech, we actually use aseptic viable spores. Ours have been created in a lab. There are other types of inoculants out there that might be growing these in greenhouses, basically chopping that up on the root system, and you can get introduced other plant pathogens that you might not want in there. That has happened before. So the issue is the current registration process has company report propagules, but we do need to start looking at the viable spores because hyperinflated numbers, again, sound good, but they're not going to be what is going to be helping or benefiting your plants in the long run.
Hey, Nate, I'm going to pop in with a question pertinent,
Yes, sir.
I think, to what you're talking about. And a doctor, Sridhar, wants to know if aren't mycorrhizae host specific? You mentioned endos and ectos being sort of crop specific, but what about more specific than that?
Yeah, so mycorrhizae are host specific. There are certain types of, there are various mics out there. We're talking about endo and ecto mic for this presentation, but there are different types of mycorrhizae out there. And once they do colonize that plant root, that is the only connection site for that propagule. So I was actually about to talk about that in a second here.
Great minds.
But yes, so when I talk about one versus all here in a second in my Bacillus slide, I was actually going to mention that with Mike, but I will answer that question here in a little bit, Chris.
All right, very good. Keep going.
So Bacillus, moving on, another type of beneficial organism that is out there in a lot of products on the market is Bacillus. And Bacillus is a naturally occurring microorganism. So chances are, if you go again out into your backyard, you take a scoop of dirt from your where you live, you're probably going to encounter some Bacillus in that. Bacillus can either be a biostimulant or a biocontrol. So how do they work? Well, when they germinate, when their spores germinate, they rapidly colonize the plant roots that they encounter, and they form a physical barrier of protection. So what we're seeing with a physical barrier of protection is exclusion. It's going to prevent plant pathogens from being able to come into contact with that plant root. And I'll show you in a second here after the slide what that looks like. As well, some Bacillus strains, like the one that we use is Bacillus pumilus, that actually excretes antibacterial and antifungal substances, such as surfactant, and it will also excrete oxidants. So what we're going to see with Bacillus is once it's established, we're going to see that it's going to suppress root rot diseases like Pythium, Fusarium, and Rhizotonium, but it's also going to increase our root growth, and it's going to see root hair proliferation. And I'll show you what that looks like now. So this first picture here is a picture of the Bacillus strain that is colonizing that plant root. So if you look in the center there, that is the plant root. On the outside of that is how that bacteria has gone around and multiplied. And now that has formed a barrier that's going to protect against those pathogens. Now, I do want to stress that this is a proactive, not a reactive measure. If you already are encountering, this in your greenhouse, or you will not be able to solve that issue using this. But if you use it at the start, before you encounter those issues, this will benefit your plants. Additionally, you will see root hair proliferation. So each one of those roots that you're seeing here, root hairs, is allowing for more water and nutrient uptake. It's benefiting your plants, and it's acting as a biostimulant. So this is what I mean by biocontrol versus biostimulant. This same bacteria is doing both. Here's another picture that I have for you all. You can see this plant has been grown in a petri dish. On the left side is our control, and then on the right side, you can see how those root hairs look like fuzz. Well, those fuzz are the root hairs from the last picture, and it's allowing for increased water and nutrient uptake. This is how it's going to benefit your plants, because you can think about our bacteria working in conjunction with the mycorrhizae. Well, if you have more root hairs, you have more sites that the mycorrhizae can colonize. And fun fact, I'm going to show you a video here real quick that we actually When we talk about mycorrhizae, they produce hyphae. Bacteria don't just colonize those plant roots, they're also colonizing the outside of that hyphae as well. It's allowing for increased protection along that secondary root system. So you're seeing thousands upon thousands of bacteria under this microscope, but that's not just around this one, that's just around this one hyphae fragment. Now imagine that around all of your plant. That's going to add for another layer of protection, and it's going to give you another benefit in your greenhouse. So what are some benefits of Bacillus? Why do we use it? Well, again, I mentioned that it's a biostimulant and a biocontrol. So in terms of a biocontrol, we, by excluding and preventing things like Fusarium, Pythium, and Rhizotonia, we're acting as a control. It will target these organisms, it will feed from the same food source, and it acts as a barrier of exclusion. So what we see with the biocontrol is we have a reduced need for fungicide drenches. On average, people typically are able to reduce it by 1 to 2, depending on their cycle and how many you use. We've seen anywhere from 25 to 50% reduction. And they also have insecticide properties. So they will eat and target the same food sources, and will limit things like fungus gnats in your media, if you've ever encountered that. Additionally, they act as a biostimulant too, because if you saw the root hair proliferation, well, each one of those sites is a new site that more water and nutrients can be uptaken. And what we're doing is we're giving more power, like to use a phrase from one of our other grower services, Lance, it's giving our roots more power to flower. If we're giving them more protection, we're giving them more sites, well, now our plant uptake is growing, our plants are growing faster, more uniform. You're going to see our vigor and yield increase. And you're going to also see our plant tolerance and environmental stress also increase. So talking about one versus all. There are many products on the market that contain multiple strains of Bacillus or mycorrhizae in them. And these are, or they might be package deals. Which one of these is better? Well, the thing is, not all inoculants are created equal. Research has shown that, we actually see better results from using one strain versus using a cocktail of different strains. And some of the reasons why we see that is because we see interspecific competition. The dominant species of myc or the dominant species of bacteria eventually is going to win out. But to answer the other person's question, it is that the myc is host specific. But the thing is it's not always optimal or practical to throw in a bunch of different Bacillus strains or a bunch of different myc strains, because not all of those have the same efficiency. A lot of Bacillus strains will colonize plant roots, but few of them actually show benefits of plants. And actually, we have seen in research with the more that we've added, the less growth, it can actually be detrimental to plant growth. So throwing a bunch of things at the wall and seeing what sticks is probably not the best solution. When we do this in trials and when we do this in tests, we actually test hundreds of different strains, and we've already determined and seen which ones benefit and which ones don't, and which ones survive. That's how we have developed a procedure to replicate them, and we've developed it and why we add it into our product. So lastly, I want to talk about the cost effectiveness of active ingredients, because everything I've set up into this point sounds good. You might be thinking, Nate, okay, yes, I'm starting to see the benefits of mycorrhizae and how they benefit. I'm starting to see the benefits of Bacillus and how they benefit, but I don't know if I can justify the cost. Well, I say this back to you. It's important for a grower to consider all of the areas of an operation these organisms can help improve. If our primary goal is to increase your profitability of your growing operation, we can only do that through two ways. We can either increase our production output or we can reduce our cost of production. So in terms of increasing our production output, we can try to grow more plants in the same square meter. We can try to increase the number of crop cycles that are grown per year. Some might do benefit where, you see 1 day or up to a week in reduction, but that might not be the best strategy. We can also increase the yield per plant. which that is beneficial to us. And we can also increase our production output by actually lowering our crop shrinkage. If more of our plants are surviving and we're not wasting those resources, that's going to increase our production output. We can also reduce our cost of production as well. So how do these organisms do that? Well, we can reduce our crop shrinkage. So when we use Bacillus as a biocontrol, we're not encountering things like Pythium, Fusarium, Rhizotonia, Alternarium, because our plants are excluding them and our plants are growing healthier. So that means we don't have to apply those chemical pesticides, those fungicides. And think about the labor associated with applying that. Things that you might not also think about is reentry interval. You know, how inconvenient is that? A lot of these things are chemicals. How does the market react to that? Where's the consumer preference at? Do they want something that has pesticides or chemicals applied to it in some of the fruit? No, they don't. These microorganisms are safe. They are non-GMO. They are natural, and they will benefit your plants. So we have to be thinking about that too. So I'm going to take you all through a little example of what I mean by that. You know, suppose a grower is growing 10,000 10-inch hanging baskets in their growing operation. They might be doing a whole lot, but let's just say that they're growing 10,000 and they can wholesale them for around $10 a basket. You know, would active ingredients be a good investment for this growing operation? Well, this is something for you to consider. You know, we have to think about this in terms of with and without active ingredients being applied. So in terms of, a lot of people might be thinking, all right, well, 10,000, 10-inch times $10 is $100,000, right? In total revenue. Well, not exactly, because we know that shrinkage, and we see that shrinkage falls this past year, fell between 4 to 7% for growers and 5 to 20% for retail. And I got that from the Floriculture Research Alliance, which is an alliance between many different universities. This is the most recent numbers for the year 22. So if we have to take that number and we look at something for, let's say around 5% for growers, and we take that 100,000 times by 5%, we can expect to lose around 500 baskets out of that, you know, and that's an estimated loss of $5,000. So if we take that, what our potential was, and we subtract that, we finish with a revenue somewhere around $95,000. Now that's not profit, that's just revenue. There's a difference. So, you know, the question becomes, well, what if we could recapture half of that shrinkage with active ingredients? What would this mean for that grower's bottom line? You know, would they benefit from using active ingredients? So let's do that example. So AI is going to be an extra cost. We can't ignore that because we're using something as a proactive approach rather than reacting to an issue that's ongoing in our greenhouses. So if we talk about ProMix, mycorrhizae, and biofungicide, we know that it's going to increase the cost per pot around 4 to 12 cents, but depending on what growing media you use, whether it's a bark mix or one of our peat perlite mixes. So if we take that 10,000 plants and we multiply that number by that, we're talking about an additional $400 to $1,200. That's something unavoidable. However, if we look at what we've reduced and we take that and we say, hey, we just reduced our shrinkage by half, you know, so instead of 500 plants, we only lost 250 plants. Now, instead of a $5,000 estimated loss, we're at a $2,500 estimated loss. So let's take those numbers up and add them up. So if we take 100,000 and we subtract off $2,500, which was the cost of the loss of hanging baskets, and then we talk about the active ingredient loss and we subtract that, well, what we see is a total net revenue increase. We're actually increasing the amount of money that we're putting in our pockets with active ingredients, because our total revenue just increased by $1,300 to $2,100 by using active ingredients. And in most situations, it's important to note that this number is just with shrinkage. It doesn't include other numbers such as, you know, fungicide drenches. So imagine if you used one fungicide drench less. That's going to save you pretty much the cost of using any of the Bacillus in your growing media. It doesn't include things like insecticides. Bacillus has insecticide properties too. What about the labor associated with that? How many people are struggling to find labor in their greenhouses? And how many people want to sit in a hot greenhouse and spray pesticides all day or do fungicide drenches? Trust me, I've done it. It's not fun and it's not enjoyable. And then you got to wait anywhere from 4 to 12 hours to go back in there, or you have to resuit up if you forget something. So again, the true number that you're saving will likely be much higher than this for this grower. So it's important to look at how much you lose per year, and then you got to do those internal calculations. So some closing thoughts on active ingredients. Initially, these may be more expensive up front, and I'm not going to deny that. However, over the course of growing, they stay with you the entire time. They're going to save you more money and energy on the back end, and you will see increased savings with that. Your customers are also going to love them, and those plants are going to survive longer. Those customers are going to remember plants that survive 3, 4, 5 months, with neglect, if they watered it inappropriately or they never fertilized it. Those plants are still going to stay resilient, and they're going to be return customers compared to a plant that looks great in your greenhouse, but 3 weeks later with their customers neglect, they're tossing it to the side. And lastly, I do want to stress that these are going to be preventative and they're not curative methods. They will not work if a disease is already present. So we have to think about this at the start. We can't just get into the middle of our growing operation and say, oh, well, you know what, let's switch over. It doesn't work like that. This is something I do want to stress. And lastly, active ingredients offer growers another tool in their IPM tool bag. It's giving you a chance to use something that is not going to, your consumers who are out there on the market right now that want less pesticides, they want less chemicals. This gives you another tool to combat that is OMRI certified and will be able to use. And when we talk about active ingredients on the market, our Bacillus strain, actually, there aren't any fungicide drenches that have a problem with it unless you're using a copper-based product. Most of your things that you use, like, for example, Xeritol, isn't going to kill our mic as well. So it's important to think that these are going to stay with you and they're going to benefit your plants. And not only do you see a benefit, but even if you don't think you will, your consumers definitely are going to see a benefit. And that is my webinar on building better plants with biologicals.
Great information, Nate. I greatly appreciate it. I'm calling you Nate now because you were calling yourself Nate. So, hey, we're on a short first name basis. We've got some questions rolling in. Go ahead and stop your screen share.
Okay.
Brant wants to know, is there, you threw out a 50% shrink reduction. Is there any research that you've done or anyone else about how much these active ingredients can actively or actually reduce shrink?
The issue with that, Chris, is that's how I did it in my example, and that's what we have seen through our trials, and we've partnered with universities. Now, it's important to note that these aren't going to be, if you're talking about a massive greenhouse operation and something like that, where their shrinkage per year is maybe 1 to 2%. Well, they might not necessarily benefit as much from active ingredients. Someone that has everything to the T. But if you think of some of our other growers on the other end that have shrinkage of 8, 9, 10%, 11% shrinkage, 12%, we actually do see it. And when you knock off even a few percentage of shrinkage, you're increasing your profit. So as far as the actual number, that's just what we've seen through our independent research. So I wouldn't say that there's a specific study that I can point to.
Yeah, your results
may vary. It is a little bit of
as
trial
they
and
say.
error.
Yeah,
It is a little bit of trial and error.
Sure. But Michelle wants to know, how long are the active ingredients viable? How long can you store a mix that has it in them?
Ooh, that's a really good question. So the active ingredients here at Premier Tech, we actually use viable spores. Okay, and our viable spores can actually, like for example, our mycorrhizae, they can stand for 2 years, up to 2 years in our products. However, that's actually not why we recommend we use our products between 9 and 12 months. The reason why we recommend we use our product before 9 months is because other things, other characteristics of the growing media can change. For example, our wetting agent can break down. So if you're using an organic product that has an organic wetting agent, that's going to be a much shorter time than any of the active ingredients in there. So the Bacillus and the mycorrhizae have no problem extending temperature inside the bales, so they're able to be stored outside as well. Or they can be stored in the greenhouse.
Right. That tied into Matthew's question, which I think you might have just glanced at.
Oh, I didn't see that
No,
actually.
storage. He was asking about storage conditions, like extreme heat or cold, freezing, anything like that.
So
I mean, it's coming out of Canada, so it's already pretty cold, right?
Well, that's the thing. So I can actually attest to Matthew. I can attest to your question. Okay, so when you buy things out of Canada, a lot of times it's stored out there in the yard. And a lot of times that peat moss will freeze. So the mycorrhizae that we use that's why I brought up the debate between viable spores versus propagules. Propagules are not going to survive, and they're going to be less resistant or resilient at that stage. But when you use spores, those spores can withstand harsh conditions. So when we talk at storage conditions outside, people don't realize that peat moss is a very good insulator. So let's say that you were growing or using one of our mega bales, which is our 135 towers. Well, maybe that top, inch, half inch, some spores might die in that. But when you get into the middle of those bags, you don't see a problem with the spore count, and the spores actually survive all the way through.
It's probably warm and toasty in there, as a matter of fact, isn't it?
Yeah. So you typically don't see an issue when it comes to that.
Yeah. Adrian wants to know, and I had this question as well, are there any fungicides that will kill the microorganisms? Expand on how you nurture the microorganisms in your growing mix, things you want to do to maximize their growth, and also things you don't want to do that would, affect their abilities.
Well, when we talk about active ingredients such as fungicides, most of what's available on the market is not going to kill off the mycorrhizae or the bacillus. However, there are different ones, organophosphates, which probably almost all are off the market. And then sometimes there's copper-based. So if you're using a copper-based fungicide, I would not recommend that, because that can kill off the bacillus and it can kill off some of the mite. Now, when we talk about fungicide drenches, it's important to know the rate at which you're using it. If you're applying it by the label and you're using it by the label, you typically will not see a problem. You might see a slight reduction in terms of their total numbers, but you got to realize that these organisms grow very fast. They're microorganisms. They're repopulating and doubling. Their doubling time is tremendous. So they might take a little bit of a dip, but they're going to bounce back.
What about PGRs? It seemed like it could actually increase the effectiveness of uptake, which could mean you need to adjust your rates. Am I reading?
So when we talk about plant growth regulators, for those out there,
meaning a drench, of course, a drench in my name.
Okay. I thought you were talking about actual plant growth regulators.
Yeah, PGR drench.
But typically we don't see a problem with what's on there. However, I would definitely say to check the label. You need to check the label, and if you have any questions, you can contact our grower service team, and you can see whether or not a specific product that you're using will work with your plants. Okay. But typically, check the label, see what's in it. You can contact them or us to see whether or not you can apply it. At most situations, you won't have a problem doing that.
All right. Lindsay's asking about fertility, fertilizer affecting, especially during that call stage early on. Does that affect the establishment of mycorrhizae? Or the salts from fertilizers in any way affect the crop?
So I'm reading the question. So it's important to note that when we're talking about, first and foremost, there are different types of products out there on the market. So for example, like when we talk about mycorrhizae, there are drenches, there are granular applications. We actually incorporate, for Premier Tech, we actually incorporate into our growing media. So they're already next to the root. Essentially, the first time that you've watered them, it's already probably started to make contact anyways. If you have a high enough dose, the mic initial won't have a problem with that. I mean, you don't want to apply it at too high of a level, but if it really depends on where you're starting out your seeds at, what you're potting. Are you doing transplants? Are you doing seeds? What are you fertilizing? What's your rate at? Are you doing at 50 ppm, 100 ppm nitrogen? You really need to know those things first. But typically we don't see a problem with that. We also include a starter fertilizer charge in our ProMix products anyways, and that doesn't have any impact on our
So
microbiome.
typical parts per million you'd use for growing a crop, 100 to 300 or 250, something like that.
Yeah, I mean, if you're starting things out in seeds and you're going in a prop house, you might be 50 to 100, depending on what you're looking at. But as you grow up, in different stages and cycles, you go from 100 to 150. Some plants, that's their limit. Some plants like 200, 220. So you really need to know what you're growing. But even at that stage, as long as the mic have already made a connection with that plant, they're not going to be impacted.
And it seems plugs and young plants would be an optimum stage to apply the product, especially if it transfers along into the 4-inch and then out into the garden. Oh, Nate's frozen. Well, we'll give him a second to see if he can come back in, or he's contemplating the question. And if we don't get him back, well, we did get through most of the questions. And what I'm going to do while we wait to see if he gets back, I'm going to pop up just in case we don't get him back. Oh, there he comes. Oh, almost. Let me share my screen real quick. Let's see. I'm going to give you his email address just so that you have it. There it is. Let me back that up for you. There we go. In case we don't get him back, he was trying to get back in there. If we don't get him back, email him your questions at WALN. That's not his radio station. Those are his initials, I think, at premiertech.com, and he'll field them for you, so to speak. All right, let's see if he's coming back in now. He's going to activate his camera. Come on in, Nate, if you're able to. If not, I've shared your email address with our audience, and so Barb, Fernando, Jaron, Bradley, you can get your questions answered. All right. Well, I think we're going to leave it right there. You got that. Another question, always, you want to watch this webinar again. There's a lot of detail in there. Go to growertalks.com/webinars, and that's where you can share the webinar with the colleagues. Watch it again. I will have it archived in the next 30 minutes or so. All right, let me stop the share right there. Nate, we got you back. You're muted though. You're muted.
Oh, I don't know what happened there at the end.
Not a problem. At least
Zoom just decided to just force close on me, and I'm sitting there trying to join in, and then it's sending me elsewhere. Sorry about that, y'all.
Wait, not a problem. Let's go through. We got time for just a couple of quick questions. I was asking when you froze. I asked. Seems like young plants, seedling, like plugs, liners, whether it's an annual, a perennial, a tree or a shrub, house plants would be a really good time to put it on, especially if it carries through into the 4 or 6 inch pot and even out to the customer. Is that a good time to apply active ingredients?
Wait, can you repeat that?
Yeah.
Are you talking about when you're potting it up?
Well, no, even at the seedling or the cutting stage, can you apply active ingredients that early in production? Seems optimum.
Well, you got to realize that if there's no roots, the mic aren't going to colonize plant roots. So until those plants have sprouted the roots, you're not going to have any way to benefit from mic or the bacillus. That's not going to target it. But once those plants start to grow, depending on how you start them after cuttings, or if you dump them in a root hormone and those plants are growing, you will see benefits. And once the plants grow and the roots give out signals, the mic is going to start going to try to grow to that
Yeah,
direction.
you showed a petri dish with basically a seedling,
Yeah.
with it already starting to form on the roots, or at
Yes,
least in the
sir.
case that case it was bacillus. So it looks like as soon as you've got a root system on that seedling or liner, that would be a good time to put it in there. So in other words, should a young plant producer be applying it a couple of weeks into the crop to share that benefit down with their grower and the retailer, et cetera?
Well, it's important to realize what products you're using on the market. I was talking about it from a pro mix where we actually perspective where we already include it in our growing media. So once it's already pre-included in our growing media and our plants are growing, we're going to eventually find that bacteria, or we're going to find that mycorrhizal spore when those plant roots germinate. Now, there are different types of inoculants on the market. Some are able to be applied via their watering system. You don't want to put it into your stock tank or your fertilizer because that's going to kill those mite. But there are a couple other ways that you can apply, like a granular mic, and that will benefit your plants.
All right. Okay. Yeah, Jaron is asking about application. Now, in your case, it's mixed into your mixes already. So they don't have to change what they do, just change their mix. If somebody, for instance, Fernando uses a production system using pumice with 10% leach every time they water. So they would have to be applying the active ingredient separate because it's not in the mix. Then he's worried about, would I actually be leaching it out if that's the case?
Typically the active ingredients will try to stay in that media. I will say in terms of using a Promex product, you're not going to leach it out. We know exactly how many spores that we put in per gram. You might lose a couple, but typically you're not going to lose near enough to affect those plants. So it depends on what you're putting on your plants. So in that case, if you're not using a Promex product and you're applying it, really look at the label. Check the label, see what the spore count is, see what you're putting on there. I don't think that you would have a problem with overhead irrigation watering and watering it into your plant.
Okay. Austin is asking the same question, but he's talking about during early propagation. And as you said, you want to wait till you have a good root system there to apply. So maybe you don't, if you're applying it separately from the soil, you would apply it after you're done with early propagation when you're applying heavy mist or heavy irrigation anyway.
So you're typically with irrigation, you're not going to wash the active ingredients out of the media. You won't have to worry about that. It's not a factor. And again, these microorganisms rapidly multiply. Once they find your plant roots, they will colonize it. And once they go, it's like wildfire. They spread up and down that root system, and they're looking for that chain. Because you have to realize that active ingredients and microorganisms, okay, when a plant is growing, it takes up sunlight, and that's photosynthesis. Well, those photosynthates are traveling through that plant, and eventually when they exit out at the root and we're excreting root exudates, the plants are doing that for a couple of reasons. One, it can be a natural defense mechanism, but two, it's already to try to attract these microorganisms in the first place. So your plants are going to be growing, and as long as you have them there in the media, they will colonize that plant eventually.
That's cool. Last question. I'm a small grower, and maybe I'm a big grower, and I want to test out some of your mix with active ingredients in it. Recommend to me how I would best trial the product.
How you would trial the product? Well, first off, I would say, where are you growing? Right? What are those parameters that you're growing? Try to make them equal. Use on the same area of your greenhouse that you're doing it. For example, if you're growing in a greenhouse, you want to make sure all the variables are the same. If you're going to be growing on a bench, in the middle of your greenhouse, you could have a quarter of that bench, one, and a quarter of the others, but you need to make sure you're watering them the same, you're fertilizing them the same. We don't want to be injecting any type of bias into this. And then you will see the benefits in your growing operation.
All right,
so that's how I would recommend to try it.
Sure, just typical trial.
I would recommend to trial it by testing it out, testing some of what you currently use against it. That's what I do. My job as a grower service representative is a couple things. I put on product demonstrations, so I work with our growers, work with professional growers, and I'll literally come in and I'll trial things side by side to show you, here are the benefits of using active ingredients, and I show you the differences of them.
I
So
think that's the way growers want to know. Show me in my operation. And
I'm a very visual person, Chris. I'll be honest, a lot of it sounds good, but once I've gotten 5-10 trials under my belt here using, I can definitely say that I've seen it. And the pictures that I pulled out today in the PowerPoint, those were actual product demonstrations that I've done with customers that work.
Well, if I still had my greenhouse over in Merritt Island across the coast of Florida from Tampa, I'd have you over to try some on my pot mums, Exicum, Gloxinia, or poinsettias.
So,
all right, let's, I already shared Nate's email. I'll share it one more time. If you got questions, if you want to set up a trial with him in the Southeast or with any of his colleagues around the rest of the U.S. or Canada, I assume that's where you would do it. And again, if you want to watch the webinar again, it will be archived as soon as I can manage at growertalks.com/webinars. And that's pretty much it. Nate, other than losing you for a moment, but it was at the end and it didn't even matter. Thanks for the great information. We appreciate it.
Thank you for having me on today. I really appreciate it today,
all
Chris.
right. And on behalf of Nathan and all of his favorite active ingredients at Premier Tech, and for my stellar ball publishing staff who work hard so I don't have to, I am Chris Beatty saying so long, everybody. Thanks, Nate. See you next time.
Bye, guys.